integration results today. So when thinking about these, if you're trying to guess them, think about what would differentiate into the thing in the integral, and that's what we're trying to find. Okay, so the integral of x to the n dx is equal to 1 over n plus 1 x n plus 1 plus c, provided n is not equal to minus 1, because if n is equal to minus 1, we'd have to be divided by 0, which doesn't really make any sense. But we will look at this case next up. So let's just check this. If we take the derivative with respect to x of 1 over n plus 1, x to the n plus 1, well, we know to differentiate this, we bring down the power, and then so we multiply by the power and then reduce it by 1. So this is equal to n plus 1 over n plus 1 x to the n, and the n plus 1 over n plus 1 is just 1, so this is equal to x to the n. So you might be thinking, what's this c here? That's just any constant, because remember, the derivative of any constant is just 0, so of course there could be a number of integrals to this function by taking c to be different values. If we need to find the particular value of c, well, there is only a particular value of c if we're given a specific sort of boundary conditions about a function, but we'll look at that later on. Next up, the integral of 1 over x with respect to x. This integrates to ln x plus c. Nice and simple. Again, I think I've shown the derivative of ln x is equal to 1 over x. This is why we get this result. Okay. Now for the trigonometric functions. So sine kx dx. I don't know if you've seen this before, but sine x cos x minus sine x minus cos x, and if you go around this way, you're differentiating. Okay, and going back anti-clockwise gives us the integrals. Okay, so, and that's obviously because the differentiation is this way and integration is the opposite way around. So we just go around the circle the opposite way around. So this would, assuming we follow these orange lines, we then divide by k as well. Minus 1 over k cos kx, and this, if you think about the derivative of this using the chain rule, we would get k over k, or minus k over k minus sine kx. The negative signs cancel each other out, the k's cancel each other out, we get sine kx. Okay, and similarly cos kx dx, the integral of this is equal to 1 over k sine kx. Okay, brilliant. So these are some nice simple integrals, but what if our integral does not take the form of any of these here? Well, this can be an issue, so we're going to look at some tricks for solving more complicated integrals. But for now, we're just going to introduce, which is if we have an integral of alpha f of x, so some constant multiplied by a function, plus beta g of x with respect to x, this is equal to alpha f of x dx plus beta integral of g of x dx. Okay, so we can use that to rearrange integrals into a form where we can calculate each integral independently. So that's it for this video. If you did find it useful, please be sure to leave it a like and subscribe to the channel for more math tutorials. Thank you very much for watching, and I hope to see you in the next one.